Hi everyone, I will solve GATE 2020 Aerospace Engineering question number 39. An oblique shock is inclined at an angle of 35 degrees to upstream flow of velocity 517.56 meter per second. Deflection of flow due to this shock is 5.75 degree and the temperature downstream is 182.46 Kelvin. Assume the gas constant R equals to 87 joule per kg Kelvin, specific heat constant gamma equal to 1.4 and specific heat at constant pressure Cp equal to 1005 joule per kg Kelvin. Using conservation relation, Mach number of upstream flow can be obtained at round off to the 1 decimal place. So for solving this problem, this problem is related to oblique shock wave. So for oblique shock wave, you can refer to the video lecture by Professor B. Babu from Department of Mechanical Engineering, IIT Madras. Before solving this problem, we will say what is oblique shock wave. So when supersonic flow passes through a concave corner or symmetric wedge, then a shock wave is generated, which is the oblique shock wave. Due to this shock wave, there is discontinuity in the flow property. So in solving the oblique shock problem, we take some assumption, which is that flow is steady through the wave, flow is 2D flow, it is inviscid, and this flow inviscid is only applied for upstream and downstream of the shock. In between this thin part of the shock, flow is highly viscous. Flow is also adiabatic flow, and there is no external shaft work and no body force acting on the body on the shock, and gas is calorically perfect gas. So if we see the streamline, then when a flow passes through this shock wave, then this flow is deflected at angular theta, and the uh, shock wave angle is beta. So if you apply the continuity, then flow parallel to the shock wave will be the same. So velocity will be same to flow parallel to the shock wave, and flow normal to the shock wave will act as the same as the flow through a normal shock wave. So this velocity at upstream is v1 m1 and downstream is v2. So if we take the flow at normal, it is u1 velocity and parallel velocity is w1. Similarly to downstream, normal velocity is u2 and parallel is w2. So if we apply the governing equation, so we will get this type of governing equation. Continuity is rho1 u1 equal to rho2 u2. Momentum is p1 plus rho1 u1 square equal to p2 plus rho2 u2 square, and w1 equal to w2. We find both direction normal and parallel to the shock. Energy equation is h equal to u square upon 2 equal to constant, which is also stagnation enthalpy, and we can write it as h1 plus u1 square upon 2 equal to h2 plus u2 square upon 2. We need some more equation to solve the equation. So enthalpy is taken as h equal to cpt because gas is calorically perfect gas, and equation of state is P equal to rho RT as gas is perfect gas. So we can get some oblique shock relation. This normal shock, normal Mach number is Mn1 is the normal Mach number, which is the normal flow is normal to the oblique shock wave. This is M1 sin beta. And using this Mn1, we can find the density, pressure, and temperature ratio. And this Mn2 can be found using this Mn1, and M2 can be found using the Mn2. Besides this relation, there is also one relation, theta beta m relationship. Theta beta m relation, where theta is the deflection angle, beta is the shock angle, and m is the upstream Mach number. So this is the theta v time relation. Now we will solve the problem. So in the problem, if you see, we have to find the upstream Mach number, and we are given the shock wave angle and deflection angle. So in theta v time relation, if you see that there are only three parameters: theta, shock deflection, flow deflection angle, beta shock angle, and m1 upstream Mach number. We have to find m1. We know that deflection angle is 5.75 degree and shock angle is 35 degree. So we will put the value in this equation. So we will get tan 5.75 equal to 2 cot 35 degree m1 square sin square 35 degree minus 1 upon m1 square. Gamma is 1.4 plus cos 35 into 2 70 degree plus 2. So if you put the calculator, use the calculator, then 10 5.75 is 0.1006947. We will also divide it by cot 35, which is 1.428148. m1 square sin square 35 is 0.3289899 minus 1 upon m1 square. 1.4 plus cos 70 is 1.74202 plus 2. So now we will solve this and multiply it by cross multiply. So first we can write this as 0.06947 divided by 2 into 1.428148. This is 0.0352539 into 1.74202 m1 square plus 2 equal to 0.3289899 m1 square minus 1. After multiplying this m1 square term and simplifying it, we will get 0.2675774339 m1 square equal to 1.070500718. So m1 square will be 4.000737896. So M1 will be 2.000184. So till one digit of decimal 2.0. So our answer will be 2.0.